Hi everyone. In today's video we have Spirent Avalanche emulating a single HTTP user on port 1. Avalanche is also emulating a website on port 2. We're using the Spirent Attero Network Emulator to simulate the network between the user and the server, and we are also going to use iTest to automate the Attero. If you're thinking that that's a lot for one 5-minute video, you are absolutely correct. On the left side of the screen, I have an iTest interactive session connected to the Attero. On the right side of the screen, I have the Avalanche runtime statistics window. The HTTP user is downloading from the server at a rate of 3.7 gigabits per second. Remember from our previous video that the time to TCP SYNAC is the time from when the client sends the send packet to set up the TCP session to the time it receives the SYNAC from the server. It is indicative of round-trip delay. The HTTP response time is showing that the client is downloading the web page in 2 milliseconds. The transactions per second window is showing that the client is downloading the web page 464 times per second. When I click the quick call menu in the iTest interactive session menu, we can see all of the available procedures. We can add delay, frame loss, duplicate frames, and out of order frames to all of the traffic or to specific traffic profiles. I can also configure the interface settings or load previously saved config files. I can even create link flaps. I'm going to use the delay loop quick call to start the delay at 1 millisecond and step the delay by a millisecond every 30 seconds until it gets to 5 milliseconds. iTest starts the quick call execution by clearing the impairments. It then adds 500 microseconds of delay in each direction to get 1 millisecond round trip delay. The Avalanche results window shows the network traffic and the transactions per second rapidly decrease, while the TCP and HTTP response times increase. As I fast forward the video from 2 milliseconds to 5 milliseconds, the performance decreases and the response times increase at every step. The messages in the iTest execution window show that the quick call procedure is finished. When I clear the delay impairment, traffic recovers to the original values. This is a quick call procedure to directly configure a specific round-trip delay value. I am going to configure it for 60 milliseconds of round-trip delay, start the impairment, and then clear the impairment again. With 60 milliseconds of round-trip delay, traffic goes all the way down to 8 megabits per second, and the response time is at almost a full second. Now that the latency is stopped, we're going to take a look at the bandwidth shaper. The bandwidth shaper allows us to enter the desired committed rate, committed burst tolerance, and excess burst tolerance. I'm going to use the defaults of the quick call procedure for 100 megabits per second of committed rate. After we start the impairment generator, we see that the network traffic decreased to 100 megabits per second, but the TCP response time stayed the same. I'm now going to stop the shaper to get ready for the last part of the video. So far we've been working with quick call procedures in the iTest interactive session window. Now I want to show you how we'd use those same quick call procedures to create a simple iTest test case. From the iTest activities perspective, I'm going to click on Develop a Test Case, enter the test case name, and choose my topology. I could build my test case by letting iTest record my commands in an interactive session, but in this case I already have the quick call procedures to use. I can simply use an open step in the test case to connect to the Attero. I then have access to all of the quick calls for the Attero session. From there I can enter the steps like I did in the interactive session. I'm going to use the same delay loop quick call and tell it to start at 1 millisecond and increase the delay by a millisecond every 30 seconds until it gets to 5 milliseconds. I am then going to clear the impairments and disconnect from the Attero session. After taking a quick look at the status of avalanche, we can then start the test. As I fast forward through the video, you will see iTest connect to the Attero and then add increasing delay in 1 millisecond increments before disconnecting from the Attero. The iTest test case is now finished. The avalanche runtime statistics window shows the performance decrease as a result of the delay. We cleared the impairment at the end of the test case, so we also see that the traffic returned to its original level. That is it for today's video. Please note that these videos are meant to be very short and they are not meant to be a complete demonstration of the extreme power of these products. I didn't quite reach my goal of 5 minutes, but 6 minutes isn't too bad either. I will try harder next time. Don't forget to hit the like and subscribe, and thanks for watching.